Hello everybody, it is another day and I have to add another component into my library. This time it's going to be the bq5105 high efficiency QI version 1.2 compliant wireless power receiver, which I'm going to be using to charge a lithium-ion battery. And this chip seems to have everything that I need because it has both the charger and the QI receiver in one chip, which is very nice. So I looked into the default KiCad library. I couldn't find the bq5105 package that this chip is using, and this is one of these packages that have a ground pad, and then they have pins coming out on the sides. And the drawing here is very good. It's much better than the drawing yesterday. By the way, the module that I was doing yesterday, I found the footprint on their GitHub, and that footprint seems to be okay. It actually looks different from this drawing. This drawing seems to be completely off. But this one looks very nice. They even specify the solder mask keep out distance. They specify everything here. So all I have to do is just convert this into KiCad. But first I'm going to create the symbol. So we need to go to the description of all the pins in the data sheet. Let's see. There we go. And I think it's probably just easier if I add the pins like this, rather like this. So we have 2, we have AC1 and 19 becomes AC2. I wonder if this table will actually copy. Maybe I could copy this table. Or rather, it does copy, but maybe it would not paste into editor. Let's see. Yeah. And it actually pastes the same way into like any editor, gedit, anything. I don't know why the PDF reader copies things that way. It's really weird. Tables don't seem to copy properly. Let me just close this one, this, and let's go to the table here. So pin number 9 would be the AD. Pin number 8 is AD. And pin number 4 on this package is going to be just one pin, so that's going to be battery. 3 is boot 1. 4 or 17 is boot 2. Then we have 7 is the charger. And 5 is the clamp 1. 16 clamp 2. 6 would be the COM 1, 15, COM 2, 11 is 2, 14 is odd, current limit on pin 12, PG&D on pin 1 and 20. Pin 18 would be the rectifier, filter capacitor for the synchronous rectifier. Okay. Rectifier capacitor, and 10 is term, and TS control 13. Okay. Let's see if that line for the pin that was active low is there, so that's fine. And I'm gonna edit this pin to be 2.54 and then apply to all the pins. Global pin size, push pin size to all other pins. Okay, now we can open the table again, and we'll just go through the through all the pins here. So, this was. Let's see. I guess they're sorted by the name, so we should get them in the same order here. No? Oh, okay. Just the ones that have the tilde in front end up at the end, but all the others seem to be in order. So AC1, pin number 2 is input. AC2 is pin 19, it's an input. AD is pin 9, input as well. Battery, pin number, let's see, pin 9, AD. Right, and then we have the, okay, we can set the battery first. So battery output would be pin number 4, that's fine, and ADN would be an output as well there. Boot pins are output 3 and 17. Output. The bootstrap capacitor. So charge, open drain output active when battery is enabled, float if not used. Pin number 7, where is the charge? Did I miss that pin? It looks like I missed that pin. No, I didn't. Pin number 7 is an output. And then boot 2 is an output as well. And clamp 2. Clamp 2 is pin number 16, an output. Pin number 16, COM, and COM2 15, output as well. Okay. Enable is pin 11. That's an input. FOD pin 14 is an input. 12 is current limit. That's an IO, bidirectional. And PG&D, you can say that is power input. Power input, rectifier output pin number 18. So that's PG&D is 1 and 20. Yeah. Pin number 18 is an output. Pin number 10 is term. Pin number 10 input. Pin number 13 is input. And that's it for this, besides this one. There's an output. Okay. There we go. And now we can just move those pins out. I'm going to use the M key to just move them out like this. And I should probably use something similar to the schematic that they use here, because that would make it easier to then verify the schematic that I'll be putting together. I wonder if there is a better schematic somewhere. There should be in the application section. Application. Is there a schematic there? There. We can use this one. So ADN, and then AD, and then we have. It's kind of annoying that this menu doesn't show the name of the pin. So I want to see what name the pin has. I want to pick the pins in order. So I'll have to do it like this. So AC1, AC2, and then we have battery, and that goes on the other side. So I'm going to press the R key, rotate it, and move it to the other side there. I don't need to move it in place yet because first I'm going to just make sure that all the pins are roughly in the right place. Boot 2 is down here. Charge is there. And then clamp is down here. Clamp 2. And number 6, COM. COM 2. Let's see. Actually, that was COM 1. So COM 1 has to be here. COM 2 will be here. And then we have pin number 11, enable 2. That will be on this side. Forward goes here. And then current limit goes here. And PG&D goes here. And I could actually make this pin invisible. Or no, actually I'll just keep them side by side. I don't like to make pins invisible. Even though KiCad supports placing the pins, sort of like if you place the pin on top of each other, they become kind of part of the same net. But I think it's better to have all the pins out on the symbol, because then you know that you've connected them. Let's see. Rectifier, that goes here. And term is here. It's getting a bit crowded here. TS control stays there. Okay. Probably want to leave a little bit of space there because there'll be some capacitors and actually mostly capacitors. And then the connection to the receiver coil. Let's see. I think I actually will move this a little bit down because I want to place the capacitors directly on the schematic. I'll have to check how much space that would take, but it would be nice to just place the capacitors exactly the same way as they've done there. Actually, let's do like this. There we go. I'll put this box around it first. I think most of the pins are placed. I'll just clean up this side. Rectifier will have a capacitor, so I can move it a little bit higher up. Control is yeah. One thing that I've been wondering is, are there actually any like lithium ion cells that are cheap that have an NTC resistor in them? Because the ones I've seen, they don't have any NTC resistor in them. They only have the connection for the power. Term is actually, yeah, term is actually better to put down there. Okay, so I'll probably have to make some adjustments a bit later when I place it on the schematic, but for now this will do. I'm going to be using this one, so I just want to get the manufacturer number right. So this is the one that has bq5105. Yeah. So this will have manufacturer number set here, and then we can go to the footprint. There. This is stencil, and this is the footprint. VQFN 1mm max height. Okay, let's get started. I'll create a new footprint for VQFN 20, and there we go. And I could start by I'm going to create the paths first. So this one will be see 0. Yeah. First of all, this is going to be a rounded rectangle, and the size will be 0.6 on the x and 0.24 on the y, and not a through hole. 0.07 here, and exposed metal, solder mask. Okay. Anything else? No, I don't think so. Okay, and next I'll set the grid to 0.5. So I'm going to be using this measurement there in the pins. So I'm going to set the grid to 0.5. Let's see, grid settings. Actually, I'm going to do it here. 0.5. There we go. And then duplicate this. And I think that's correct, yeah. So there's going to be 9 pins here. 4, 5, 6, 7, and that's 8, 9. 1, 2, 3. And then we can copy the whole thing, duplicate, and there's 3.3 there, so place it at 3. Now I have to change the grid to 3. Let's see, 0.1, 3.3, like that. And next I can create the pins there. They can be rotated. And let's see, so where is the let's place the pins first. And this one came off grid, so I have to move it. So I guess we'll have to go after, in this case, after this one, 4.3. So it has to be 2.15 from the center, and the center is going to be over here. Okay. And you gotta be careful here, because if the grid was set wrong, then I would actually be moving it like that. It actually ends up being wrong, so I have to move one pin first and then move the rest. Oh, actually, I had too many pins here because I was counting from number 1 over there. It's 1, 2, 3, 4, 5, and then becomes 9 pins, but it's actually, because this one is 2, then it's 8 pins on this side and 4 there and 8 on the other side. Okay. I wonder if there's a function for this. Somehow maybe centering all the pins. And this one is at minus 1.65. And this one, or actually, we have to adjust the Y as well. This would have been easier to do in Python. Is there no distribution function in KiCad? Distribute paths. Although that won't work. It needs to be. That needs to be done manually because otherwise I don't know the exact distance between them. Let's see. Maybe I could do like this. So if I move that one to this would be let's see, 0.25 there, 1, so 1.75. And this one at 75. And if I do distribute now, This should do it. Yeah, and that position was correct. Okay. That kind of makes sense. And 0.75 to the side then. Yeah, 0.75, that's correct. And then this one, so the way this distribute works is that you place the edge pins where you want them, and then when you do distribute, it distributes all the inner pins. And this seems correct. I'll double check later. Although directly to this point, so that's 3, and we should have, let's see, yeah, 1.9. Yeah, that's correct. So that would be 1.9 to around there. And then this one is at 215, so we can just copy this and duplicate. And it's impossible to edit all of them at the same time. I was going to grab them sort of directly at the coordinate 0, and then I can just go down here to 215 there, like that. And then I'll create pads that I'll also number the pads later, but first I'm going to create the pads for the for this thermal pad. But I'm going to be doing it out of 4 different pads. And the good thing about that is that when they then place solder paste, it's going to go to these pads. And if you have 4 of them, then you will have slightly less solder paste, which is good when it's underneath the chip, because otherwise the chip will lift up and you will not have any contact with the pins if there is too much solder paste here. So we want to at least make sure that on the solder mask or on the solder paste layer that we only have like four squares on this thermal pad where the solder paste is going to go. Let's see, that would be 170. Let's see. So apparently if you rotate the pad, it doesn't preserve the X and Y here. So like X becomes Y. Okay. 0.75 there. So 0.75, and I can just add this one. And this can be just a rectangle. And it's actually not precisely 75 because the pad itself is 24 there, so let's make this like 70. It's actually 74, precisely 74. Like that. And all of this is going to go to pad number 21. So let's copy that one and place it here. I wonder what would be the best way to do this. Let's do like this. So I'm gonna resize this one so that it is, let's see, so Y is there. So it's going to be the same size as the full width and height of this pad, but I'm not going to put any solder paste on this large pad. So it's going to be 2.05, and this is wrong. So to do it like that, and 3.05. And then I'll just remove the the front paste. I'm just going to add the thermal bias. So they're using like 3. It doesn't really matter exactly where they are, but I still want to have them aligned to the grid. That just makes routing easier. Do they actually have the same pad on the back here? Yeah, they should have. Yeah, so this would be on the top, and on the bottom it's just going to be underneath the solder mask. So this one is pin number 21 as well, and then let's place another one there maybe, and another one. Like that. And then this one will just be copied to the back. So I just copy it and put it on the back layer. And it's not going to have any mask like that. And now we can actually look at the 3D viewer and see what the footprint looks like. So we obviously don't have any solder paste, which is bad. So we have to fix this. We're going to add. I wonder if it's. I think it's actually good to have solder paste there. So the only thing I'm going to do is add a few squares over here. So I could even just duplicate that one. This would actually be much better. So we'll have a square there. In fact, maybe even like this. I'm not gonna bother with this exact placement there. So I'll do this first, and then I'll check what it looks like. I think it's going to be a little too little solder paste. And doing it like this. Yeah, that's too little, and that's very weird. That's a very weird pattern. Let's just make them a little bit bigger. It's almost easier to just delete them and duplicate them again. Yeah, that should be good. And this all the solder that is going to be there, it's going to be reflowing throughout this whole area. The squares are just to limit the amount of solder mask that we get there. But one of the things that I don't want here is actually I have to make this one a bit smaller, because this is going to be one huge window in the stencil. So it's going to be a lot of solder paste here. Let's just go back to this part. Maybe what if I just delete that? Or if I just do like this. Obviously deleting it is wrong, but we can remove the solder paste from them. And that's a bit better. The problem now is that these pins are not going to have enough solder, so we do need to put something there. But it would be kind of nice if it was just a small piece there, so that it they're going to create a small hole in the stencil, and then there will be just a little bit of solder paste there to fill in the blanks. So I can do it like this. Doesn't actually need any clearance. I think this is okay. Yeah. So let's number the pins, and then actually I'll move it a little bit more there. So, it's better like this. that's good. So, pin numbering. Number 1 is there. Pads, renumber. Number 1, 2, 3, 4, 5, 6, 8, 9. So then it's 10, and then it's 11 here, because that one is 21. 12. No way! Oh, I pressed escape again. I'm so used to pressing escape when trying to exit the edit mode that I pressed escape in KiCad, forgetting that it wasn't Vim. 1, 2, 3, 4, 5. Yeah. Can it restart? No. Okay. I wonder how this works. So if I select that one and then create pad from selected shapes. Okay. Oh, there we go. I should have looked at this one. Okay, I see. This datasheet is very well detailed. I like this. So this is how it's supposed to look. Each one of these is 1 millimeter, I guess. Now 0.85 there, it's like 0.92. Yeah. Probably doesn't matter if they're a little bit smaller. I should have been using a Python script for this. Yeah, that looks very similar to what the datasheet says it should look like. So I'm going to leave it at that. And I'm going to add the silk screen and the fab layer. So let's choose the line and go to the silk screen. Let's see if there is any silk screen here. Or rather, the size of the package should be here somewhere. There. 3.6, 4.6. Okay. And pin number 1 is going to be here. So we can just do like oh, that's ugly. Probably something like that. Just to make it painfully clear that that's where the first pin is. For this, let's see. Courtyard, we can add for chips like this. I think it's important to have a bigger courtyard because all of the pins have to be laid out on the sides of the chip. You cannot do anything on the underneath the chip or on the inside. So you have to lead them out on the outside, and then you're going to have bias here. So placing any components within this area is inappropriate. Then I have the fab layer, and that's going to be just let's see, just like that. and that's obviously, yeah, that's not placed correctly. Actually, I'm going to point at this pin. So, screen. Like that. That should do it. Okay, bq5105, and we're going to assign it to this part. bq5105. And then I'll just run the script. Let's see. So what I'm doing now is updating the component library so that it contains all the latest information for the new components. So for example, this is our new chip here. We know that it's 1,400 of them in stock, Mauser. And we have a description and life cycle, price, and most importantly, the manufacturer number. We know that it's correct. So that's it. This component is done, and I'm going to be placing it on the schematic. Thanks for watching. Bye.